Hallo zusammen. Hi everybody, my name is Michael Ries. I'm a Principal Program Manager in the Azure Data team at Microsoft. And today I'm going to show you how you can bring big data and data warehousing together with Azure Synapse Analytics. Now let's just jump into it. During the presentation, I will introduce you to how you can modernize your big data workloads with the modern data warehouse pattern, and will explain to you exactly what that is. I will then go through the capabilities of Azure Synapse Analytics, which among other things allows you to implement that modern data warehouse pattern. I will dive a little bit more into details on what are some of the cost improvements that Azure Synapse Analytics gives you over traditional ways of providing that modern data warehouse pattern. I will take you on a walk through the experiences of Azure Synapse Analytics in a demo, although given how big the product is, I will have to limit myself to a few key demo aspects. And then I will summarize and give you a call for action. The Harvard Business Review last year did a survey among business leaders to figure out how they deal with analytics strategies, etc. And the idea that they found is that analytics and AI is definitely the #1 investments for many businesses. However, they still struggle to maximize return on investment, partially because they need to become mature users of data, partially because they identify data silos and data management difficulties of their data as potential roadblocks. So let's take a look at some of the traditional ways that people have been doing data analytics and data warehousing. So the standard data warehouse pattern is that you have a bunch of data sources out of your OLTP systems, such as your CRM, line of business applications, ERP systems, etc., which you then extract, transform, and load into a data warehouse that is designed to answer the questions that you want to have answered for your analytics in BI, reporting tools and dashboards, etc. Now, this pattern has worked pretty well, but with the increasing data volume, with the advent of new data sources and data types, such as non-relational data, sensor data, social data feeds, etc., and also the advent of cloud-borne data, the traditional data warehouses on-prem have been creaking at the seams. Now, there are data warehouses in the traditional sense also available in the cloud, but they often have the same issue that all data warehouse approaches have, which is that they are designed for the questions you know. What that means is that once you schematize your data for the questions you know inside your data warehouse, normally the data sources are kind of ephemeral, they disappear, the data expires, etc. So you don't have necessarily a history of the data to be able to ask new questions because the data is gone and the data warehouse that you have is designed for the questions that you already have. So people have, over the last 10 years, developed a new approach called the data lake approach. Now, the data lake approach is starting out with ingesting all the data, regardless of the requirements, into a data lake. Now, that data lake obviously needs to be organized. It's not just like you put the stuff in and you never find anything. So you still have to be diligent about how you organize your data inside your data lake. But the important part is that you store all the data in its native format without schema definitions, unless they happen to be already defined with a schema. And then you do your analysis with your analytics platform of choice. So you could, for example, use something like Spark or Hadoop to do batch queries, interactive queries. You can transform the data into a data warehouse and then do your data warehouse processing there. So a data lake is not really a competition to a data warehouse. It is a useful and, in my opinion, necessary step in the modern data warehouse pattern that combines with the data warehouse to be able to answer your questions. Now, while the data warehouse is designed for the questions that you already know and have, The data lake is normally designed for the questions you don't yet know, but you can always go back and find the data, analyze the data for answering the new questions in the future. Not only that, you can also use AI and machine learning algorithms running on the data to potentially find the questions that you're interested in answering. So if you look at the modern data warehouse approach, it basically takes this big data lake, experimentation, fast exploration, support for unstructured and semi-structured data approach, and combines it with the proven security and privacy, dependable performance of relational data warehouses that can also operate on operational data. So in Azure, you can build a modern data warehouse using a few of the building blocks that we have in Azure today. So you can, for example, use Azure Data Factory to do your data ingestion into the data lake. You can use Azure Data Lake Storage as the store where you place that data. You then can use Azure Databricks if you want to use Spark, or Azure HD Insight if you want to use the Hadoop ecosystem to prep and train the data and basically then move it into an Azure SQL data warehouse to do your model and serving and visualize it through your reporting such as Power BI. Now, with the advent of Azure Synapse Analytics, we are making this a much simpler experience for you and hopefully introduce some savings for you as well. So Azure Synapse Analytics is combining these experiences underneath a unified experience using the web portal Synapse Studio. It gives you analytics runtimes to do your data preparation with Apache Spark and your data reporting and data warehousing using SQL. It offers you a common data estate over the data that you have inside your lake, so you can use the same data, including tables between Spark and SQL, and you can still use all the existing tooling that you have that knows how to talk to SQL, such as Power BI, Tableau, etc., to build your reports out of Azure Synapse Analytics. So that means that you actually have the ability to use your Azure Synapse Analytics to answer questions ranging from the modern data warehousing. We want to analyze data coming from multiple sources in variety of formats to actually run your more advanced analytics on it using machine learning algorithms, etc. And in the end, you can also do your real-time analytics, trying to get insight from your devices in real time using streaming, etc. The way that Azure Synapse Analytics is basically built is if you create an Azure Synapse Analytics account, or workspace as we call it, you're associating an Azure Data Lake storage account with it. That storage account basically is ready in terms of security. It's optimized for analytics and also allows you to handle things like the common data model. The Synapse experience itself gives you kind of a unified management, security, monitoring, and Metastore kind of experience, which is one of the values of Synapse being integrated, that it takes away a lot of the pain of setting up that more complex piecemeal modern data warehouse pattern that you had to do before, where you had to handle security in each different component separately, where you had different management tools, where you had different monitoring experiences, and you had siloization of your data and metadata. Synapse includes the Synapse pipeline experience, which is based on Azure Data Factory, which gives you the ability to do data movement and orchestration. It gives you the two analytics runtimes. One is called Synapse SQL, which is consisting of two experiences. We'll go into more detail later, although we are merging those into one over time. And as well as the Spark experience, which gives you the big data processing with Python, Scala, and .NET. The form factors you have specifically for Synapse, you have both a serverless on-demand experience as well as a provisioned experience that gives you the ability to pre-provision resources to manage certain expected workloads, for example. And last but not least, you also have multiple languages that are suited to different analytic workloads and also to your different knowledge of these languages, so that you can use the language that is best suited for the task and that you're most familiar with. Languages that we are currently supporting is obviously SQL, and on the Spark side we have SQL as well, again Spark SQL, Python, .NET, Java and Scala support. And then on top of all of that, we have the Synapse Analytics Studio on Power BI integration, which gives you a SaaS developer experience for code-free and code-first experiences in Synapse. And then on top of that, you then basically can put your business intelligence applications, etc. And also you can use any kind of workload on that platform, be it for artificial intelligence, machine learning, Internet of Things scenarios, business intelligence, intelligence apps, etc. So now let's take a closer look at some of the capabilities that we are providing. And we have here Synapse SQL, which gives you basically T-SQL using both a provisioned and serverless on-demand model. We have Apache Spark for Synapse, which gives you the ability to both do notebook and batch processing using a variety of the existing Spark languages. We have Synapse Pipelines, which allow you to build end-to-end workflows for your data movement, data processing, and data orchestration and workflow orchestration scenarios. And finally, the Synapse Studio, which kind of ties that all together in a unified UI experience in the cloud. Now, in terms of Synapse SQL, the provisioned version is basically SQL Data Warehouse. So this is already in GA, even though it is part of Synapse Analytics, which in its other components sometimes is in public preview right now. You will get a lot of these capabilities. I will just point out a few. For example, we have obviously materialized views that you can use inside your SQL Data Warehouse. You have the ability to use a bulk load wizard in preview. You have prediction scoring. You have access to shared Spark table in the serverless model and soon in the provisioned model as well. You have SQL merge support and a couple of other capabilities that are making its way into the public preview over the next couple of weeks and months. On the Spark side, all the offerings currently are in public preview. It is based on the Apache Spark distribution, but with some extensions that we provided. So for example, you have Synapse Link access to Cosmos DB for the HTAP scenarios, which is basically the hybrid transactional processing experiences that allow you to do analytics on transactional data that lives in Cosmos DB a little bit easier than if you would have to set up the replication, etc. yourself. We also provide support for the open source version of Delta Lake, currently version 0.6. We have CDM support in preview. We have .NET for Apache Spark. Hyperspace Index View is a new capability that we are adding that give you similar kind of materialized view capabilities over data frames. We, again, can share the tables that you create in Spark with Synapse SQL. There are built-in samples, template code for notebooks, and obviously the really good Ntract-derived notebook experience as well. On the Synapse Pipeline side, again, since it is based on Azure Data Factory, a few of the capabilities are currently in GA. And a few other things that we are working on, such as data flow, CDM support, are things that we are looking at enabling in private preview at some point in time. One of the major aspects here, which kind of ties into the overall integration and making it easier, is that we are providing private endpoint support via managed virtual networks for the Synapse experience. So that means you can basically secure your Synapse experience and have an integrated experience with a managed virtual network as well. And you will see that when I go through the provisioning steps in the demo. And then last but not least, Synapse Studios basically gives you this ability to manage virtual networks. It has a couple of wizards, the notebook infrastructure that I mentioned, both and integrated monitoring for your SQL pool, for your Spark pools, for your Spark job graph debugging, etc. And we'll take a look at that as part of the demo as well. So now let's take a look a little bit about some of the cost benefits that Synapse gives you compared to having a bits and pieces approach to the modern data warehouse architecture. And let me first start with some of the component cost benefits that are specific to the components as we have them in Synapse. On the Apache Spark side, I already mentioned that we have .NET support, which should give you a lot of reduced training costs for your big data developers. You don't have to retrain your developers to learn Scala or Python. Now, it doesn't mean that you have to retrain your Scala or Python programmer to use .NET, but it means that the .NET investments that you have done, the code that you already have in .NET, for example, to do featureization or so, you can reuse in the context of Apache Spark, including your ML.NET libraries. Furthermore, we've added the hyperspace materialized views. Now, these materialized views basically pre-compute and then maintain the results of data frame expressions, etc., so that you have faster query results if you are having queries that are using those data frame expressions at a later point. It also means that you have smaller, cheaper clusters that you can use to achieve the same tasks, which gives you a cost saving in terms of resource utilization and finally dollars as well. On the Synapse SQL side, again, one of the benefits of using T-SQL and the existing SQL data warehouse T-SQL experiences, you can reuse existing tool sets and your existing skills and work within with the background of your familiar T-SQL environments. The Synapse SQL experience is provided in two models, in a serverless on-demand model, where you're paying exactly for what you use. So you're not having any over-provisioning, which means that, and you only pay for the duration of the query, which means that you are getting basically a really good cost structure there. Also, because you don't have to manage or monitor any clusters, you will have lower maintenance costs there as well. Now, the provision model gives you the ability to manage your workload groups to maximize resource utilization. And it also gives you materialized views and result set caching, which again leads to faster queries and smaller, cheaper clusters that you have to provision to achieve the same result. Now, because we are integrating with Azure Data Lake Storage, we are also benefiting from some of the cost optimizations that we get with Azure Data Lake Storage. By disaggregating compute and storage with a shared metadata layer, the disaggregation means that we now can scale our storage and our compute separately. That means if we have a large amount of data, but our processing is fairly lightweight, then we don't have to over-provision our compute. On the other hand, if we have reasonable size of data, but very complex computation, then we don't have to over-provision ourselves in terms of storage. Furthermore, Azure Data Lake Storage gives you lifecycle management of your data between different tiering, etc., for optimizing your total cost of ownership. So if you have data that is, for example, not being used frequently, you can put it onto a lower grade tier where you pay less at the cost of a slightly, of course, increased latency. And you have other ways of managing your total cost of ownership, obviously. And then the other thing is that the data lake storage component has been designed with analytics workloads in mind. So that should give you lower compute resources because of the higher performance and throughput that the storage provides to the compute. Now, we also have integration benefits. So integrating all these components in Synapse and integrating with ADLS gives us some additional benefits besides the individual component benefits. So obviously having a single management portal lowers training costs. You don't have to train people in 5 different management experiences, etc. Having a shared security environment means that security policies will only have to be applied once. And the shared managed virtual network gives you an easy way of setting up this without having to go and do micromanaging all these permissions and setting up the network yourself. By having a shared metadata experience, data owners also have to define some of the data models only once, and have then the ability to query it with whichever compute they want without having to do copying of the data. Furthermore, the integrated workload monitoring, again, is part of the single management experience. It reduces the monitoring and diagnostic cost of learning new tools, etc., and potentially not understanding how things depend on each other if you're looking at, for example, orchestration. And last but not least, ADLS has just released a new capability called query acceleration, which allows you to push certain expressions down into the storage layer. And Azure Synapse is now integrating this so that it's going to give you faster queries and, again, smaller and cheaper clusters. So let me now dive into two of these experiences. First, let me dive into the shared metadata experience. So the shared metadata experience at this point means that you have Spark databases and tables that are backed by Parquet. They become automatically available in Synapse SQL Serverless and Synapse SQL Provisioned soon in a couple of weeks from now as external tables of the same name. The benefit is that you don't need to run orchestration jobs to move the data or the metadata between the computes yourself, and there is no duplication of the data at the storage level. So let me show you how this works conceptually. So if I go into my Spark experience and I create a database and a table into the Synapse Hive Metastore, this information will now be auto-exposed into the SQL Serverless experience, into its own local system catalog, and it is exposed as the same database name and the same table name in the DBO schema. Furthermore, if you are provisioning a Synapse SQL instance, and this is going to be lighted up in the last quarter of this year, you have the option of selecting to auto-expose metadata objects inside that provisioned Synapse SQL DB. Now, because SQL Data Warehouse today cannot query into another database, the way that these tables are being exposed are that we are creating a schema of the name of the database prefixed with a $sign. And we are then creating a table in that context of the same name. And again, this is an external table over the Parquet files that are backing. So, which then means I can use select star from $dbs or .t1 in this case, or select star from dbs1.dbo.t1 in the Synapse SQL Serverless experience to query that data, as I can query obviously the data from any of the Spark clusters as well. So now let's take another quick look at the Synapse integration with ADLS query acceleration. What it does is it basically allows me to push down column projections and certain predicates into the storage layer from the compute, which means that I now can do filtering and projection at the storage layer and thus reduce the amount of data that I have to transfer on the network from the storage layer to the compute layer. So that means it reduces my total cost of ownership because the analytics framework doesn't need to parse and load as much data, and I also have less latency because the data is now appearing much faster because I don't transfer as much data. Now, this is going to be deeply integrated into Azure Synapse Analytics for improved performance and costs. We are looking at providing that later this quarter in the Spark Engine experience. And for next year, we are looking at adding this to Synapse SQL experiences as well. So now let me switch over to the Azure Synapse Analytics demo. In particular, I will be going and showing you the overall experience of Synapse, how to provision, etc. And I will also show you some examples on doing some query processing directly in it as well. In particular, I'm having a bunch of Twitter CSV files that I have stored inside my Azure Data Lake storage. And then I'm going to data prep this with my Spark, with some Spark Scala code. into my shared metadata experiences as Parquet-backed managed tables in Spark called mentions and topics. That data preparation could theoretically be used with query acceleration. I will kind of show that some examples there. Although right now we haven't it running yet in my cluster, so I can't show you that at this point. Then I will be using my interactive.NET experience for .NET for Spark experience, doing some analysis to see what I have been up to over the last 10 years based on my tweets. And then I will use my Synapse SQL experience to seamlessly analyze who I was interacting with. And then conclude that obviously with some additional insights about some of the capabilities that we have. Okay, so let me go, and here is the Synapse portal. So I've gone to my portal.azure.com, logged in, and now I'm going to create a new Azure Synapse Analytics resource. So I go here to my Azure Analytics workspace preview, and I do say create here. So let's do that. Now, creating an Azure Synapse workspace is a fairly simple task. First, I have to go and, let me zoom in. I have to provide some project details, such as which subscription that it is under, meaning where is the bill being sent, what resource group I want to use for like doing common management of all the components within. And then also to see what my workspace name is, which region I would like to create it, and which Azure Data Lake Storage Gen 2 account I want to associate with it. And as you can see, we have a whole bunch of regions already available. These are the ones available as of time of me recording this demo, and we are adding more as we speak. And once I have created this and given this information, on the Security and Networking Setting tab, I go and can set my SQL administration credential for my SQL pools. I can use system assigned managed identity for my SQL pools for pipeline integration. And I can select to enable a managed virtual network, which obviously then makes my experience more secure. And I can decide which IP ranges I want to have access to. Now, I'm not going to create one right now. Instead, I'm going to switch over to the pool that to the workspace that I already have created for myself for the demo. So you see here now the overview of my Synapse workspace. Let me zoom in here. So you see here that this is Invest US2 right now in an internal Big Data PM subscription. It has some workspace URLs here that I will be showing you in a second. And over here it shows which primary ADLS Gen 2 account and file system it is associated with it. What is the SQL admin username? What are my SQL endpoints for my SQL on demand, which is the serverless experience, etc. And then down here, you see resources that I have created. So obviously the pipeline is already there. You will have a SQL on demand SQL pool resource here that is already existing, but you can add additional SQL pool instances by basically provisioning SQL Data Warehouse instance. So as you can see here, what you do is you provide your SQL pool name, you provide your performance level that you want to have, and you will get an estimated price for it. Let's go back. And you can add Spark pools. Now, I've already created a few, but let me show you what it looks like if you create a new Spark pool here. So at the basic level, you are creating a Spark pool, give a Spark pool name, and then you provide the node sizes, which sizes you want to have, whether you want to enable autoscale or not, what the range of your auto scale is, and then what the estimated pricing is. And obviously there's like additional pricing details and based on whether you have an enterprise agreement, etc. So these numbers might be different. Now let's look at the node sizes here. We give you 3 sizes right now. Small is 4 virtual CPU, 32 gigabyte, medium is 8, 64, and large is 16, 128. Once you decided on that, you go and set some additional settings. The additional settings are kind of important to be able to manage some of your cost control. So you basically have the ability to say that once a pool gets instantiated, that it will be auto pausing after a certain number of minutes after idle time. So what that means also is that if you create a Spark pool, you're not actually creating a resource. You are creating a template that will be instantiating the resources once you connect to it or once you start up that pool. And we'll see that when I give you some usage of these Spark pools later in the demos. Furthermore, it shows you which component version you have. You currently have Apache Spark 2.4 with these Python and .NET Core version and .NET for Apache Spark and Delta Lake. Furthermore, you have the ability to upload an environment configuration file for Python packages if you want to have them be automatically deployed when the pool gets created. We are working on adding support for .NET libraries and Scala, Java, jar files as well in a future update. So again, let's go back here and show you the pools that I have here. So for example, I have a Spark Analytics pool here. You can take a look at the auto pause settings, the auto scaling settings, etc. That I have. So currently it's auto pause after 30 minutes. It auto scales between 3 and 3 nodes. So right now there's not a lot of auto scaling possible at this point because I try to keep it small. So now I have this provisioned. And now how I actually going to use it? Well, I can click on this workspace web URL that we have here. And I already done that. And that takes you into the Synapse Analytics Studio experience. And the homepage, you kind of see what you can do with it. You see some recent resources and things that you have used and opened. And you can go and explore and analyze and visualize and learn more about this. You can also go here and create new scripts, notebooks, data flows, Power BI reports, pipelines, or import something. Oops, I didn't want to click that. So after you're looking at the home button, you can look at these other icons here. And each one of these icons identify a specific hub. The first one is the data hub. So let's take a look at the data hub quickly. The data hub basically gives me 2 places to look at. It gives me the linked data where I have linked services, including the file system. Let me switch over to this at the moment. And this gives me the ability to add Azure Data Lake storage accounts, Gen 1, Gen 2, Blob Store, and others by basically linking them. Also like integration data sets, etc. And I can navigate that here. So let's look at my data lake here at the moment. I have some tweet data here that I mentioned earlier as part of my demo inside my ADLS Gen 2 folder here. If I preview one of these files here, you will see this is a CSV file that has 4 columns. A date, looks like a time, looks like who has been tweeting, and then there is some tweet data here, basically the actual tweet content. So that's kind of the data. These are different people that have given me their tweet sets, so I'm kind of looking at those going forward. Now, in addition, besides the linked data sources, there's also workspace integral data sources, which are basically the databases. And so if I open this up right now, you see there are a couple of databases. They all having Spark at the back there. So these are all databases that have been created by Spark. If you look at here, you see the mentions and the topics tables in this context. Now you can again go and add new Synapse SQL databases, or again connect to external data sets, etc. If you want to, for the linked part. Now, having said that, even though these databases and tables are created by Spark, you will be able to create a SQL script on top of that table. So we'll take a look at that in a minute. I can basically create some notebooks or scripts directly on these data sets, or I can go into my development hub where I have the ability to create SQL scripts, notebooks, Spark job definitions, or if I add a Power BI environment, I can also add Power BI data sets and Power BI reports, and we'll take a look at many of these. So let's start with some Spark job definitions because I have my tweet data sets here. So I want to go and basically run a Spark job definition that creates the tweet data sets. Now, let me open this. So what you see here is that I have written a .NET for Spark program that creates my tweet tables. And I could now go and submit this to the Spark pool down here. Now, I'm not going to do that because I already created my table. So I actually have another program that I want to show that is a little bit simpler, which is called Ignite Demo here. That is basically a simple Spark application, again, written in .NET. But you can see you can do batch submission using Python and Scala as well. No, I don't want to do that. And then I can submit this. Now, submitting this will be submitting the Spark job. The first thing that will happen is that it will actually create a Spark cluster instance based on the pool definition that I have submitted it to. I also have the ability to go and set properties here. Such as, moment, that's not the properties here, they're down here, move down here. So you can see now I go against the Ignite demo Spark pool that I had earlier. I'm using 4 executors with a medium executor size here to run this. And at the beginning, it will now create the cluster infrastructure. Now, this will take a while. We are faster than most of our competitors. It takes about 1 minute to 3 minutes, depending on how large the cluster is that it's getting created. And then eventually it will have submitted it, and it will give me the link here to follow. Jumping forward in time, we now have reached the time where it has been submitting the job. So you see here it took about 2 minutes to submit the job and create the Spark pool. You then can go into the Spark monitoring URI down here to actually take a look at how the job progresses and works. So let me click on this. So this is now showing basically how the job is progressing. It shows me a nice stage graph here. Obviously, I have a very simple application that I'm running, so it's not using a lot of processing and a lot of stages here. And this is running. You see again, total duration is 2.5 minutes. So it basically ran in a few seconds after it completed the spin up of the cluster. Obviously, if I now go and resubmit to the same pool another job with kind of within the resources and execution sizes that I specified, what actually will happen is that the next job is not going to be recreating a new cluster. It's reusing the cluster that has been created already. So now let me look at the standard out here, which is the result. And you will see here that I actually went through my tweet data and looked at some author information and how many times I think they got mentioned or something. So kind of a nice little program here. Now, if I go back to my Synapse experience, in my development environment, I can also develop code in some of the tool and have an experience that allow me to submit it directly out of the tool. So let me show you that. Right now, the only language where we support this as of now is with IntelliJ and Scala and Java, obviously. So here I have IntelliJ with a simple log analytics program here that basically does some Apache log analysis. Now the logs here are in main memory because it's again just a simple demo program. You see here that I'm using Scala Spark to create my Spark context, and then I create the data set, have some user-defined functions that I create here, and then basically down here I take the data set and I do the extract keys and extract stats. I do a reduce by key collect for each, and basically do this. Now I can connect to my Azure Explorer experience here, to my subscriptions, and find my Azure Synapse workspace, and also find my Spark pools inside here. So that means I can now go and configure a new configuration here that allows me to submit this. So I can go to my run debug configurations, click the add sign, select Apache Spark on Synapse, and then basically create a Spark on Synapse configuration that allows me to submit my job remotely in my cluster. I select my workspace and my Spark pool that I want to submit it to. I again specify the executors that I want to use, provide additional arguments and files if I need them, and then I basically have this created. I can then go and submit it through the Spark job run up here to submit this against the Spark cluster, and it will be submitted, and I can track what's happening down here. So this will be doing an all integrated compilation, building, submitting it to the cluster, and then basically letting me know down here that I now can go into my Spark history server or Spark job details UI, which is the one that we saw earlier, in my browser to take a look what happens. So I did submit that earlier. So let me go back to my experience here, and I go down here to the monitoring hub. And on the monitoring hub, I have I can obviously look at my pipeline runs, etc. I can also look at my Spark applications. And so down here you see I had my Spark on Synapse log query that I had submitted. So again, it looks very similar to what I had earlier in the other job. Again, if I go down here to standard out, you will see the query gets answered with basically this log that it had registered. Now I can do playback here. Obviously, in this case, short job, so the playback is going to be a little bit unintuitive. I can also click on the Spark History Server. That gives me kind of the standard Spark History Server experiences that that you might be used to from Apache Spark. So you get basically both experiences, a more Synapse experience and a more Spark History Server experience. Now, because I don't want to spend too much time on that, let me continue and show you the notebook experiences that you have. So now I have basically created these tables that I have talked about earlier. I can obviously also do the data prep using a notebook. So here's the notebook that basically does that data prep that I've seen earlier. What this does is it creates a extract user-defined function that it will be applying. It creates the tweet data frames by reading all these tweet files that we have seen earlier, schematizing them, doing duplicate elimination. And you see we eliminated 185 duplicates. Then I registered the two Scala functions as Spark user-defined functions. One time I extract mentions, the other time I extract topics. And then I basically extract these mention and topics first in a combined data frame. Then I want to pivot them and extract only the mentions and only the tweets. And once I've done that, I clean up some existing databases and create a new database by basically saving the data frame after repartitioning it into one partition, because I have fairly small amounts of data, only 30,000 rows and 18,000 rows, and write it as corresponding tables inside that database. Now, this I submitted as a Scala notebook to a Spark pool called Spark Data Prep. Now, these tables are also available for querying in other notebooks. So here I have a .NET notebook that is using another Spark cluster called Spark Analytics, Spark pool, sorry. And what this does is it basically allows me to look at my top 5 quarterly tweet topics in bar chart format. Remember, I wanted to figure out what I was up to in the last 10 years. I can use the built-in Plotly library in the .NET Interactive Notebook here to do some nice visualization. You notice here I basically take my Spark data frame that I defined up there. I execute it, get the result into my main memory inside .NET, and then I apply some link queries to basically transform the data so I can create my visualization. Visualization is down here. So you can see I have like 3 humps between 2010 and 2020. The first hump, I was working on SQL Server, spatial support, XML support, and other beyond relational capabilities. I was presenting at SQL Bits. Then I became quiet on Twitter because I was working on some internal projects and as well as preparing for the next project, which was Azure Data Lake and uSQL. So you see me tweeting and being active on that. Then again, I'm getting quiet because I move over to basically start working in Azure Synapse and .NET for Spark. And so you can see that I'm starting to tweet on this. And by the way, just a shameless plug, I have way more detail on how to use .NET and Spark together using Azure Synapse in my other session. So I highly recommend that you go and check that one out. So now I have created that table and made it available inside my Synapse workspace. I can also use SQL to query that table. So what you see here is simple SQL query. Let me hit run here, which is now using looking at the mentions table and do a group by count number of mentions where I have more than 5 mentions basically, or 5 or more, and show that down here. Now the first time you run a query in your serverless SQL experience, it will take a few seconds, about 10 to 15 seconds to provision the resources. Now if I run the query again, you will notice it's going to be executing much faster. It's like about a second or less. Now, the visualization that we have both here and in some of the Spark notebooks is that you can have a tabular representation, but you can also switch it to charts. So in this case, let me do a column chart based on my authors. And so now I have a nice visualization of who has mentioned me the most in descending order, so that I can basically do some simple analytics. Now, another thing that I can do in my development tab here is I can actually connect to Power BI. So I can open my Power BI data set here. So currently I have a tweet analysis data set and a sales and return sample data set that I have loaded here. I can create new Power BI reports by clicking on here, or I can use one of the Power BI reports that I have already created. So let me open one here. And that gives you the ability to basically look at, do way more advanced reporting, and obviously share these Power BI reports with others as well. So this one here is the sales and return sample Power BI report. You see the visualization tabs and how to select fields, etc. So you have like the whole experience of Power BI directly built into your Synapse experience as well. Now, you have to use Power BI Desktop and to, for example, build your report the first time and then basically link it to your Synapse workspace to get that done. So this is this. Now, if I go back, for example, and look at my Spark job definition, I can click this add to pipeline icon up here. Now, what that means is that I can now create a pipeline that is either adding to an existing pipeline or creating a new pipeline that would be going to allow me to orchestrate this batch job in this case. I can do the same for notebooks. So I can go, for example, to my notebook here and again click that icon up here and give me the ability to add it to an existing pipeline or create a new pipeline. So that means it's very easy to start combining these components into pipelines. I can also go into my orchestration hub here and do the same thing from there. I can create new pipelines here or use the copy data tool to author a one-time or scheduled pipeline to load data from over 90 data sources. So let me, for example, create one quickly. I can create some task description. I'm only doing it once. So now I can, for example, say what data source I have. For example, in this case, let's see, I can go to Azure, for example, select something. I can create databases. So can create new collections here. So there's a lot of abilities that I can do. I can then say, for example, which files I want to do, etc. So this is the standard Azure Data Factory kind of UI experience that you have here to create your orchestration pipelines. And then last but not least, as I mentioned, you can do your monitoring of your experiences, both on the orchestration side and the Spark and SQL requests. So here, for example, right now we don't have any active SQL requests, so you don't see any here. You can also go in here and, for example, manage your SQL and Spark pools also from the tool, your external connections, etc., and your security access control. So let me now go back to the presentation and conclude and summarize. So I think with the release of Azure Synapse Analytics, we have given you a really cool integrated experience to build analytics experiences and modern data warehouse patterns. It gives you a breakthrough in the cost of enterprise analytics performance by integrating SQL data warehouse. So as you can see, we did in January 2019 a data warehouse TPCH benchmark report by GigaOM that shows that Azure Synapse Analytics is up to 14 times faster than other cloud providers. We are giving you an easy way of building end-to-end solutions with a unified experience, which gives you low cost of maintenance and management costs and financially backed SLAs. And finally, you also have a good integration into the BI and machine learning experiences to get insights for all users, for the data scientists, for the data preparation, data engineer, to the business user with Power BI and other tooling that can access relational data sources. We are also protecting sensitive data in real time. We have high security. We give you industry-leading security and privacy features at no extra cost for you, because that's part of what we are doing as part of our Azure offering, etc. Now, to summarize, Azure Synapse Analytics is a limitless analytics service with unmatched time to insight that delivers insight from all your data across data warehouses and big data analytics systems with blazing speed. Simply put, for people that wonder how this relates to SQL Azure Data Warehouse, it is basically the next step, the evolution of Azure SQL Data Warehouse from a pure relational data warehouse to a modern data warehouse pattern experience using Azure Synapse. Now, to conclude, let me give you some homework. First, check out my other SQL Bits content, the big data processing with .NET and Spark, if you want to learn more about how to use .NET and Spark and see more demos. If you want to get introduced to Azure Data Lake Storage, go to aka.ms/ADLS. If you want to get started with Azure Synapse, go to aka.ms Azure Synapse. The QR code that you see there can take you there. You can also leverage an offer that we have between Informatica and Microsoft to help you migrate data warehouses that are in so-called legacy data warehouse systems into Synapse. There is some cool offers there that you can find at aka.ms/Synapse Informatica POV. If you want to connect with me, you can tweet at me at Mike Does Big Data. You can tag it with SQL Bits and Azure Synapse if you want to refer to this presentation. You can find previous slides and at some point in time also the SQL Bits slides at my SlideShare link. Again, that link can be reached through the second QR code on this deck. Thank you very much for your interest, and I hope to see you explore your data and do cool reports using Azure Synapse Analytics. Thank you.